Okay, section 10.7 is areas of circles and sectors. So the first thing we're going to look at is the area of a circle. We should all know this. The area of a circle is the product of pi and the square of the radius. Area is pi r squared. So real simple, if we have a circle with a radius of 6, the area is pi times r squared, 6 squared, and we always put the 36 in front of the pi like it's a coefficient. So very simple area of a circle. A sector, excuse me. The sector of a circle is the region bounded by an arc of the circle, my arc AB, and the two radii to the arc's endpoints. You name a sector using one arc endpoint, the center, and the other. So this is sector AOB, or I could call it sector BOA. Either one works, as long as you go from the endpoint to the center and then back to the end point. Okay, so theorem 10.12 says area of a sector of a circle. So to find the area of a sector, it's the product of the ratio of the measure of the arc to 360. Again, that's the part of the circle that I am using, times the area of the circle. So written algebraically, the area of sector AOB is the measure of arc AB divided by 360. That gives me the fraction or the part of the circle times the area of the whole circle. So let's do an example of this. So find the area of a sector. What is the area of sector GPH if the measure of arc GH is 72 degrees and the length of the radius is 15 inches? So I'm going to draw a picture. And I'm going to do a sector, and it's GPH. And they said the measure of the arc is 72 degrees, and the radius is 15. So using my formula for the area of a sector, it's the portion of the circle, 72 360ths, times the entire area, which is, pi, pi r squared. 72 360ths can simplify to 1 over 5 times pi times 225, the square of 15. And 5 goes into 225 45 times, so I can just simplify that to 45 pi. All right, so sometimes drawing the picture helps. If you don't need it, that's fine. We have one other thing to look at, and that's the area of a segment. The segment of a circle is the part of a circle bounded by an arc, in this case ED, and the segment joining its endpoints. So the color section here is the segment of a circle. So how do we find the area of that segment? So what we're going to do is we're going to take the area of the entire sector, POQ, and we are going to subtract the area of the triangle, PQO. All right, so the area of the sector, the entire thing, is our 120 divided by 360 times pi r squared minus the area of the triangle. Now the triangle is a little tougher because I don't have a height. However, if you'll notice, this is a 60-30 triangle. So my ratio here is this side is 1 to 2 to 2 root 3. I'll draw the triangle off to the side so you can see this a little better. So this is my 60, this is my 30. I already know that's 21. So this has to be half of it, and this has to be half times root 3. So the area of this triangle is 1/2 the base, 21 over 2 root 3, times the height, 21 over 2. Okay, did I do that right? 1, 2, yep. So finishing this off, I've got 1/3 times 441 pi minus 441 over 8 root 3. This does simplify to 147 pi minus, I don't think that I can simplify this fraction, so I'm just going to leave it. And if you need a decimal form, you could go to your calculator. Okay, so we will do a few of these in class, but that's it for your note.